Okay, hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms. So the date is 2025 May 23rd. The time is 3:40 a.m. I was trying to go to sleep, but I failed miserably. So here I am, just recording it. I mean, I couldn't fall asleep because I was worried that I might forget what I had to say for what little things I did for the past 2 to 3 days. So yeah, since the very point of making these videos is to record as many steps as possible, and also for me to not forget the thought process and the processes of how I did it and what I thought and how I thought and how I got to the results and the mistakes, etc., etc., etc. So finally I have started doing what I called the dynamic genetic algorithm. And what is dynamic genetic algorithm? I honestly I don't know if there should be a term for what I'm about to explain and describe right now, but I was just too lazy to look it up, and I know that I might just be trying to reinvent the wheel or retracing the steps that people have already taken. But the fun is in the journey, is it not? So, what is dynamic genetic algorithm? And I'll do this in the reverse order. So, dynamic, and then right before dynamic there was what was it? Oh yeah, tracking individual entities, and then what was there? What else was there? So, tracking individual entities, and before that, or somewhat simultaneously, or before I started tracking individual entities throughout the generations, there were also general genetic algorithms, and there was just kind of basic, not basic, but just preset gen algo. Versus preset gen algo. Now, when I say general, it means that the item values were generated from distributions. Yep. And while I was doing this, the very first thing I did was basic or vanilla Is that how you spell vanilla? I don't know. Yeah, it is double L. Basic or vanilla genetic algorithm. Algo. And whilst doing this, I looked into a lot of things. Firstly, there were a few ways of setting up the evolution scheme. Parent selection, max constraints, and max constraint percentage, CSTRNT percentage, and well, so many other things. But sorry, hold on. Where's my water? So when I have this, what happened to? Oh my god. What? Really? Okay. But whilst doing that, all the things that were just listed here but somehow disappeared had one thing in common, and it was that items and their utility values, or sometimes just called values, and their constraint values, or sometimes called weights, would be fixed. As in, if the items were fixed, it would mean that the total number of items would also stay fixed, and each value for utility and constraint would also be fixed. So if, for example, if the backpack, if the number of all items was set to 20, which is what I initially started with, not 10 but 20, that's usually called num items. Items would be set to 20 and it would stay that way. And then in this list of items there would be the items, 20 items that an entity could choose from, or 20 genes, for example. So and amongst those 20 items, I could have my MacBook, which would have a value of 200, utility value of 200, and a constraint value of maybe 1200. So maybe this is in grams, for example, and 200 units of some imaginary convenience value or use to me. But anyway, so utility value higher the better, constraint value lower the better, higher the worse. And another item, I could try my phone, and it would have a utility value of 300, whereas the constraint value of my phone would be something like 400 grams again. So that's the whole gist of it, and they would stay this way. But if things were to suddenly become dynamic, all of this could change, or it should change. So For example, the number of items could change to suddenly either 15 items or 21 items or 29 items or just 30, and then on to 40, and then on to 50. Or I could just, go all the way halfway down to 10. So that's one thing. Or if it's dynamic, the value of MacBook could change. It could go from 200 units to 174 units. Yeah? Or even the constraint value could change. Suppose I needed to maybe plug in something to my laptop that and then I would need to consider that setting as a whole, as one item. So now suddenly my MacBook suddenly weighs not 1200 grams but 1800 grams. And maybe if I change my phone to a better one, which would give me 450 utility values, units of utility value, but which somehow got lighter as well, so 380, something like that. So all of these things could change, and if these things change, well, naturally, the max constraint can also change, or should change as well. Max constraint will change because now there are more items, or now something is worth more or worth less for the same amount of weight, or for the same amount of constraint, or for a lower amount of constraint or a higher amount of constraint. So the maximum constraint can also change, or sometimes maybe the maximum constraint is set by the maximum constraint percentage. You never know. And also, and in some rare cases, the although the initial population may not change, not likely, but the what I call the normal population, or just pop, might also have to change, or might change, or the max population, the absolute maximum population, might also have to change, or can change. And on top of all this, the items themselves could be preset, as in values like these, or generated, or general. But for now, I'm going to focus on the preset values. And well, when I do that, this is what I get, and I'm going to start typing. So there's the util vals, and then I didn't know that was a feature. I didn't know I could do that. What? Okay, let's try again. Do not press tab. So there's util vals, and then there's constraint vals, and then there's the chromosome length, or same as number of items. Yeah, that's about it for now. So for example, if the utility values are fixed, they can be fixed or will be fixed. If we leave the utility values at fixed, then we can have the constraint values at fixed as well, and the chromo length can also be fixed. Now this is something that we've been doing so far, so pass. On to the next one. Next, the utility values can still be fixed, and the constraint values could be varying values, they could change, and the chromo length can still be fixed. So TLDR, there are 8 possibilities after choosing to do it with do all of this with preset values. And then if the utility values are fixed, we can have the constraint values fixed as well, but the chromo length be varying. Okay, and the utility values can be fixed, and the constraint values can be varying, and the chromo length could be varying as well. So that's 4 of them. Okay, and the next up, the utility values can be varying, the constraint values can also be varying, and the chromo length could also be varying and shifting and changing. Next up, you know what I'm going to do, you already know, and the constraint values could be fixed, and the chromo length could be varying. Next, again, varying, constraint values are fixed, right? Yeah, fixed, and then fixed, and then lastly, not the least, it could be varying, and the chromo length could be fixed. So there are 8 possibilities, and this one I've been doing for the past 2 to 3 months. So now I need to do the rest, 7 of them. And so far I've started on fixed varying, which is this one, where the number of items will change, and of course it could go up. The number of items can increase or decrease, and the first that I'm doing so far is increase. So this is where the number of items, so far the notebooks that I have created, in them the number of items start from 10 and then goes on to 20 after some generations, and then it goes on to 30, 40, and then 50, and then end of one evolution iteration. And the purpose of doing this is, or was, to see if given the LR method and the candidate method and the candidate percentage, which for now it is set to propos tail, and the candidate method is expo tail, and the percentage is 0.2. So given this, will I get a nice distribution of entities where I consistently, not always, it doesn't have to be always. If it's always, it's a problem, and I've already seen why that's a problem. But not always, but consistently be able to get the best possible answer, the best possible entity within a few, or within a certain window of generations per era. Now, what is an era? An era, I've decided, is when something doesn't change for some time. For example, if the number of items start with 10 and then stay for 10 for some period, for example 70 generations, then this 70 generations is an era. And then next era, in the next era, the number of items is 20, and then maybe it stays that way for another 200 generations. That's also an era. Another era where number of items is 30, another era where it's 40, another era where it's 50. So that's how it goes. So the first thing is to, if this is the max or the total sum of utility values, as in only achievable when max constraint percentage is at 100%. So first thing I want to see and be able to do is ensure that after all these eras have passed, ensure that I get a nice robust distribution towards the end. Maybe not touching this, but something like this, or something like this too. Anyway, you know what I mean. And then the second thing, but not less important, the second thing is to see if I can get a to see if with the help of the summed utility plot, the average summed utility plot for the head, top 10%, top 50%, and the tail, to see if I can, like I said, consistently get a healthy and robust population or healthy world where the head entities are the best possible combination of genes, and a very thick or healthy average or median healthy number of median entities, and the tail, the left tail of the distribution, or rather the tail entities at a reasonably high or decently high or reasonably low sum utility level, and also no peaks, no dips. So I don't want this, I want this, and I want this. That's usually what I worked for. This is for the heads, this is for the top 10%, and this is for the top 50%, and this will be the tail entity. So this is what I usually want, but if the eras, if there were to be different eras where the number of items increase, in this case only increase, no decreases here yet, I haven't started that yet. So anyway, if the number of items can only increase and do only increase, then the summed utility plot, for example, for the head, will look like this, or should look like this, and it does, like a like a staircase. The same goes for the top 10%. What color is that? The top 50%, and the tails as well. And well, spoilers. I do get these lines. I do get this plot, but there's a catch, and we're about to see the issue that I have been challenged with. So let me just check. Today I have some sheets of papers that I could refer to. This is the first where I actually have some notes that I took when I did this, because it was so much to think about and remember. But anyway, so first, here's the notebook to generate the entities and the metrics and their performance. Well, and here's the notebook for, this is the first version of the notebook for analyzing the results, analyzing and visualizing the results. Yeah. So I will go deeper and deeper into this, so I can just have a look at these plots on the notebook on Google Colab for now, and then I can start looking at the actual plots that I saved from different settings, different evolution settings. So I do. This is after what, probably 500 generations, or was it 3,000? Yeah, in this case it's 500. Can you just imagine the reason I, for a few times, the reason I set the generation to 3,000? I'll get to that. So here's the entity distribution. Nice, yeah, just as I imagined. And this was achieved by using the, like I said, the learn rate method, candidate method, candidate percentage, being proper tail, export tail, and 0.2, which is 20%. And here's the summed utility plot, the average summed utility plot. Now, this is exactly how I pictured they would be, but here's the very first that I did, and where is it? I can't find it. Is it? No. What is the very first one that I did? Sorry. There's so many of them, I just keep, it's hard to keep track of all of them. This is where it shows that I'm really not that good at organizing stuff. Yeah, here we go. No, not that. 500, and here we go. So this is probably the very first proper thing that I did, and you'll see that I do see the steps going up like that, just as I imagined. I'm not lying, I imagined it would be like this, and it actually was like this. Now, the only problem here is, well, without looking at the legend, it's not a problem yet, but it will become a problem. You'll see why I say that. Without looking at the legend, not just yet, you'll see that the smoothness of the step, which is for the heads, the red lines for the heads, the smoothness is falling off, as if the steps are being worn down. It's really smooth here, it's a bit jagged here, it's more jagged here, now this is even more jagged, and this is not smooth at all. I mean, yeah, if you draw a line, there's an average, but it's not smooth at all. And so, and you might say, oh, that's not exactly a problem, because here in this era, in this era, there are 50 items, 50 genes, so it might really be very tricky to constantly and consistently have the very best. And then if you look at the maximum ever, where did it go? Oops, sorry. If we look at the maximum ever, it's 1505. Oops. Why is it 1505? That's the maximum ever. ¿Por qué? Why? Because from the millions of videos that I've done so far for the past few months, I know that the maximum it could ever actually be is somewhere here, which is, yeah, you guessed it, 1540. So I'm missing 35. And it's not just that I'm not getting anything. I mean, well, it is just that as well. Where's the rest 35? But the thing is, no entity has ever reached that, not even once. That's a problem. Because, where is it? Entity plots, maybe not there. If we look here, this is general genetic, tranquilo. This is fine. We'll have a look at 04. From one of the ways that I did the evolution, this is one of them, and you can see that even when I'm using this, the LR rate, the fixed universal learn rate of 40%, and the candidate method being range, where the start decile is 0.6 and the end decile is 1.0, meaning from the bottom 40%. the heads constantly and consistently reach the maximum ever, that is 1540. As early as generation 100, or maybe even before that. And the heads do falter off a bit here as well, but then again they do recover, and a few more times there. So what happened? Look, what happened? I'm not getting anything here within the 100 generations. So maybe I was unlucky. Maybe that was the case. Maybe, yeah. So I did another one. Where is it? Yeah, this one. So I did another one, and now it's 1510. No entities reached the 1540 mark, and it's not like they were constantly at 1510 all the time. There was only one occasion, or maybe one or two, out of the 100 generations. So the next one, it's still 1510, and the next one 1525, slightly better. 1515, yep. And then what? So I did when I increased the generation to 1000. Nothing else changed. I only increased the number of generations to 1000, and I still got 1530. So I bumped it up to 2000, and it was still at 1530. So I bumped it up to 3000, and finally I've had one or maybe a few instances where the maximum ever was at 1540, but not that many times. Each era here in this setting is 100 generations, so 100, 200, 300, 400. So for the next 2,600 generations, there were only a handful of instances or generations where the head entity was actually the best possible combination of genes. This is disturbing. Very disturbing. So what happened? Well, let me just look at my notes again. What else was I gonna say? Yeah. So it seems that as the era changes from one to the next one, it seems that the entities become too or slightly too biased or prejudiced, and this means that when new elements or items or genes are introduced, or maybe removed even I'm sure it will act the same. The same phenomenon will happen when they're also removed, as in when the number of items decreases. But anyway, entities become too biased or prejudiced. Choose your favorite word. And the pre-existing entities do not have enough information. But then who does? Because at generation 0, no one has enough information. But yet, when we do it, no, let me try that again. Sorry. Huh, on Windows I don't have open on the same tab. I didn't know that. So, for example, where is it? Proper tail 02. So, it's not like, no, this isn't good. I want this one. This is proper tail. This is it. Yep, here we go. So when this is the exact same setting for 500 generations, but only plotted until generation 120, where I do constantly and consistently get the maximum ever at 1540. But here, even when this happens, it's not like even when I have the setting like this, oops, it's not as if when things start here, entities have any information about what's good or bad, what genes are good or bad, or what items are good or bad, and yet, nevertheless or regardless, they do learn, and then go all the way up there. It's like there's no information. They do learn, and they do reach that point within what? At around 75, 70 generations. Definitely by 80 generations they do. But it seems that when we have something like this, by the end of each era, entities become biased and prejudiced, and because now there's already a distribution at each point, something like this, something like this, something like this, and something like this. There's always and the thing is, when a change occurs, this distribution may not be robust enough to cater to those changes in the next era, because so little information exists that could potentially make things better. And then when that happens, the same thing could happen here as well, like no information there or whatever. And what used to be good can be bad as well as the era changes. I mean, that's the whole point of this, right? Being dynamic. And these effects may stack up. They might also cancel out each other. So, but in general, they will add up. And when we're at the last or the second last stage, what would have been bad here, or could have been harmful here, could now, given the new circumstances, could be good here. But the thing is, those entities died. Those entities are no longer there in the world for them to learn and procreate. They're either in the struck out group or the limited group. So so there might be a couple of candidate solutions, possible solutions. The first thing that I actually have done is change the length of eras, change the width of eras or length of eras. For now, it was, for example, this one was at 100, 100, 100, 100, 100, so in total 500. And when I did, where is it? When I did, where did that go? Where did it go? There we go. When I did this, it's this whole thing is 2,600 generations. But when I say change things, I could do it so that when I'm given I could do it in a way that for 10 sorry, need some water. I could do it so that the first era only lasts for something like 20 generations or 30 generations, and then the second generation slightly more, because in this case there's there are more items, right? In this very case, there are more items. In the third in the third era now, so 30, maybe 45 in the next era, maybe 70 here, and maybe 100 in the next era, and then the rest of something, so that they add up to a certain number, maybe 500 in total, maybe it's 500 in total, maybe it's 2,000 or 3,000, etc., etc., etc. So that's one way I'm looking into right now. Another way of doing this might be so two more. Another way of doing this might be we come back to the entity distribution, and I remember having chosen the learn rate and candidate method combination where the resulting final world entity distribution looks something like this. But maybe I picked a combination where the median height is too high, maybe it's too tall, maybe they converge, maybe the set of methods that I chose makes the entities converge too much, and well, hence the higher bias or the higher prejudice. So maybe I need to choose some other set of methods where the distribution is wider, but the average would still be lower by some amount. So that when the world, or when the entities move on to a the next era, for example, the set of methods that give a distribution like the red line would have little information coming from here. That could be the key to innovation or higher or consistent performance. But if I were to have a distribution that is slightly wider and decently with decently high sum utility values, maybe then I might have a lot more entities that can provide that key to innovation, so that in the next era they still perform like this and they start hitting the actual best possible combination of genes, and then in the next one after that as well. So that's another way of doing that. So what did I cover? This is come on. This is oh, come on. Era manipulation. Seriously? Why did it do that? This is era manipulation. And then the next one is fine. This is wider entity distribution. This is wider entity distribution. Thank God I spelled that right. And the third one can be one or two or a combination of the two things, which is per generation or per n generations. It could be per every generation, or it could be per 2 generations, whatever. Introduce either void chromosomes or void entities, or introduce randomly generated chromosomes. Again, chromosomes. Yeah. And this is something that is not in my notes, but I could, now that I think of it. Well, now that I actually think about it, I could actually maybe try using some other procreate function as well. Some other procreate function. But again, the purpose of using another procreate function would be to have a wider distribution, wider entity distribution. And the purpose of introducing either one or all of these two things would be to have, what is it? A wider entity distribution. Not that wide, not too wide, but wide enough. Yep. So let's just have a look at the plots, but in no particular order. At 10 items it was 365, the maximum ever, which is correct. And at 20 items it's 710, which is also correct. And it actually converges at around generation 20. Or is it 30? I think it's here, so it's 20, late 20s. Yeah, and with 30 items, the maximum ever is 945, which is correct. At 40 items, it's was it 1135 or 1140? I don't know. Where's my note? 1135. So that's correct. So when done separately, they still do work. But when done in a chain fashion, or in terms of eras, as a sequence of eras, it doesn't always work. It should always work, as in I should always be getting some entities that actually have hit the best possible, or the true ceiling. That's a good word. True ceiling. True ceiling given the maximum constraint. And I'm not getting that. Even when I have it at 3000, when I have the generation set to 3000, now I get it. But not that many times as well. I should have been. Actually, if you really look close, I don't even get those instances that often. But like proper tail 0.2. If we look with the same setting, with the same learn rate and candidate method and candidate percentage, I am constantly getting 1540 after generation 100. There's always an entity or two at the very true ceiling. So that should happen, but it didn't happen. It is not happening. For a very long time. Because of the bias that may have stacked up before in the previous eras. And it's not like when the generation is set to 3000, it's not like I'm guaranteed to have 1540, because I don't. As you see here, the maximum ever was 1535 in the 2600 generations that were given. There were no instances, no entities that actually ever hit the true ceiling. Same here as well. So this is the first of many challenges and obstacles that I'll be facing. And what's funny or sad is that this is the first combination that I have actually set to cover, and I already have a huge number of problems, a huge number of questions and issues. I mean, just as when I thought I'm done with the fixed, now I have to deal with the rest 7 of these, and then when I'm done it will be onto chaotic. But the thing is, even doing this is tricky, because when I have done this, I also have to do when I have when I'm actually done with the setting where the number of items steadily increase as the eras go on, I have to try a setting where it may it may increase and then maybe decrease and then increase, or decrease and decrease and decrease something like that. Or start with 50 and gradually decrease as well, all the way down to 10 items, something like that. 50, 40, 30, 20, 10. So if I wanted to cut it off at every 10 items, there are a lot of possibilities. For example, if I start at 20 here, I could go up or down, and then I could go up or down, I could go up or down, I could go up or down, up or down, up or down, and this will never end, by the way. For how many eras? I don't know. For how many generations per era? I don't know. So that is why I'm trying to focus more or imagine more about the general way of doing it. I don't know why I just circled that, but a general way of doing it. It could be this, or achieving this by this. Who knows? I have no idea. So that's about it for today. Well, that was 63 minutes. And it does feel good to let everything out of my system. Well, the time is 4 AM. Thanks for watching. Goodbye.